Alright, well I actually recorded this once and it didn't record, so I'm getting to do it twice, so I definitely know what's going on. This is graphing systems of inequalities. Yesterday we did just regular systems of equations. Now we're doing inequalities. So just a couple things to remember from before. When you have less than and greater than, less than and equal and greater than or equal, you are going to use a solid line. Okay, when you go to graph it, this means that the solution does include the points that are on the line. If it is less than or greater than, there's no equal sign. You're going to use a dashed or a dotted line. Okay, it will look like that. Because this solution does not include the points on the line. Alright, when it is greater than or greater than and above, you will shade greater than or equal. You are going to shade above the vertex if it is a quadrilateral, or above the line if it's linear. If it's less than or less than or equal, yes, you will shade below the vertex if it is a quadrilateral, or a line if it's linear. You can always pick a few points to check if you don't want to use that way. Alright, so the solution to a system of inequalities. Okay, we were working with like the quadrilateral and linear last class. Your solution would be where they cross. Well, these are inequalities we're going to be shading. So today it's going to be the double shaded area. Wherever both areas that you shade cross, that will be your solution. So we're going to do 3 quick examples here. I feel like I've done them before because I have. So anyway, the first one, it's quadrilateral. The bad thing is it is in vertex, not in vertex form. So it's in standard form, so we have to use x equals negative b over 2a to find our vertex. So in this case, x will be a negative 8, that's our b value, over 2 times our a value is 1. So we have 8 over 2, which is 4. So now I know my vertex will be at 4. I need to find the y value. So plug it back into the equation. Y will equal 4 squared minus 8 times 4 plus 15. So 16 minus 32 plus 15. You can grab a calculator, or 16 and 15 is 31. So 31 minus 32 is a negative 1. That is my vertex. Now the very nice thing about this has no stretch or compress because my leading coefficient is 1. So that means I can graph my parent function from this vertex. So go to 4, negative 1. It's positive, so this graph will open up and it will just be my parent function. So from here, 1 squared is 1. 2 squared is 4. And 3 squared is 9, so I'm up 5 more from there. Did I count 5? 1, 2, 3, 4, 5. Yes, that's correct. And I can reflect these across the axis of symmetry, which goes right down through the vertex. And 1, 2, 3, 1, 2, 3. Alright. So here I have my graph. I come back over to see that it is just greater than. There's no equal sign. So I'm going to connect these dots with the dashed line because the points on this actual line are not included in my solution. And then it says greater than. So I will shade above my vertex, which is this area. If it were less than, I'd be shading below. Now it will go up a little bit, but at least it tells you which side. So this is greater than, so I'm shading this area in here. Okay, the next, it's a linear, so that's nice. And look at this, it's already in slope-intercept form, mx plus b. So my y-intercept is 1. I graph it. My slope is 1/4, so it's up 1 over 1, 2, 3, 4. And then up 1 and over 4 should take me to 8. And we can go down 1 and over 4, and down 1 and over 4. Make sure you have a good line. Count quite a few points. Now this one, if I look over, it's got the equal sign. So I'm going to do a solid line because it will include the lines, the points on this line. And now it's greater than, so I'm going to shade above my line. If it was less than, it would be down here, but this is greater than, so this is the area. So where is my double shaded area? It's this section, not down here, but just this section right here. So go back through and sort of make that a little darker so we can see that this is my shaded area. This is the answer where they have that in common. Now a lot of times I'll come back and I'll ask, are these points part of the solution? So is 4, -1 in the solution? 4, -1 is my vertex. Number 1, this is a dashed line, but it's not in the double shaded area, so that's a no. Is 4, 4? 4 up 4, yep, it's going to be right in there. That would be a yes. All right, number 2. We've got another quadratic with a linear. Look at this. That is my what? It's my parent function. Just move it up 1. I love this because I can come over. Normally your parent function starts at 0, 0. We're going to move the whole thing up 1, and from there we'll go 1, 1, 2, 4, and then it will be 3, 5, which should put me up, or 3, 9, 3, 9, which should put me up at 10. So then reflect those points. And it is a less than or equal, so because the equal's in there, make this one a solid line. And it is less than, so below my vertex is down here. Now even though it's down here, it does go up on the sides. We've done these before earlier in the year, so hopefully you remember all this. Now what we're going to do is just graph the linear function with it. It's at +5 is my y-intercept. My slope is a -2. Make sure that your slope is going this direction when you're done, that it's falling. So if you go up 2, you have to go back 1. Up 2, back 1. We can come down to a +1. 1, 2, +1. Like I said, count out quite a few points. It just makes it so that you have a good line there to graph. I come back and check. Oh, this is just a greater than. It doesn't have the equal. So I'm going to do the dashed line on this one. And it is greater than. So this one's a little harder to tell. But going down this way would be less than. Above is greater than, so we're going to shade this side. And then you go, where does it double shade? It's going to be this section right in here. So again, make it a little darker, grab a different color or something so that you can see that's my double shaded area. Is 1, 5 a solution? 1, 5, oh, it's up in there. That is definitely not anywhere in my double shaded area. 5, 1, over 5 up 1, boom, that would be a yes. And 2, 1, 2, 1. That falls on the dotted line. Is the dotted dashed line part of my solutions? No. So this one's a no because it's on a dashed line. If it had been a solid line, then yes, but it wasn't. So quickly we're going to buzz through one more here. Another quadrilateral with a linear. Yeah, yes, we're back in standard form. So we've got to find our vertex, which is -b over 2a. So I get a -4 over -2, which is 2. So now my vertex will be at 2. I need to find the y. So plug it back into your equation. Now be careful. The negative is on the outside. The 2 is the only part being squared. So you square the 2 and you get a 4, and the negative stays in front. So -4 plus 8 is 4, minus 1 is 3. So my vertex is at 2, 3. And if you look, it is going down. So this time I'm going to just do my parent function. There's no stretch or compress, just going down. So I'm going to count 1, 1, 2, 4, and 3, 9. That should be right. Reflect it across. and it does not have an equal sign, so this will be a dashed line. And it is less than, so I will shade below my vertex, which is on the inside here. Go over to graph my line. I do not have a y-intercept, that means it's 0. So I'll start at 0, 0, and I'm going to go up 2, back 1, up 2, back 1, rinse and repeat. Or from 0, 0 we could go down to positive 1, down to positive 1. I've got a whole bunch of points there. That will give me a great line, and before I do it I see there's no equal sign. We're dashing again. Dashing through the snow. No, it is not Christmas time. Do not sing Christmas songs. There we go. Greater than. You're shading this direction. Above. What do we have in common? This little section right in here is my double shaded area. That is the solution. All of those will be solutions to both of them. So, is 0, 0 solution? It's on the dashed line, and that, if it's on a dashed line, it's not included, so no, not the solution. How about 0, negative 1? Again, it's on a dashed line. Nope. So surely 4, negative 1 is 4, negative 1. It is once again on a dashed line. No. Trick question. None of those were solutions. All right, we are done.